In this session, today we'll be learning about Python exception handling. So in Python exception handling feature is also available that we have seen in other languages. So again we are coming to the same thing, learning by doing, that whatever concepts we'll be learning today, you must practice it so that you are able to understand the problems and difficulties that you are facing during implementation of these concepts. So you will be learning better by practicing it. So these are the topics that we'll be covering today in this session. First, we'll be learning about what you mean by errors. So we have three type of errors. One is syntax error, another is runtime error, another is logical error. Then we'll be learning about exception model, exception handling, and in exception handling, we'll be learning about try and except blocks, in which we'll be learning about multiple except clause, single except to handle multiple exception, generic except after all the excepts. Then we will be learning about else and finally block, then raising exception, assertions, user defined exceptions, exception hierarchy, and then references from where we have taken the content of this presentation. So starting with exception, so we are aware about the term error, right? So in our daily life, we also do errors or mistakes. So similarly, in when you are doing the programming, you definitely when you are writing the program, if you are starting with your programming career, or even you are the expert, so sometimes you may do some mistakes while writing the program, right? Or not even writing the programs, you can say sometimes your logic, when you are thinking about how to solve this problem, so sometimes you are not able to understand the problem and you write the program in other way than it should be. So these are all mistakes, these are all errors that you use to do while doing the programming, right? So errors or mistakes in a program. So now we will be talking about, because we are talking about programming, so we will be talking about errors or mistakes in a program are often referred to as bugs. So basically, this is the technical term bugs when you talk about errors. So sometimes we say that, okay, now I am debugging my program, right? So what you mean by debugging means you are removing the errors from your programs. Okay, sometimes you are saying that, okay, please, can you debug this program? It means you remove the program errors from the program. So they are mostly, we can say, this is the fault of the programmers, right? Because when you are writing your program, you are not aware about the syntax and you try to write the syntax, and that if it is wrong, so it means this is a fault, this is an error. So the process of first is finding, because till you do not find the error, you cannot solve it. The problem of finding and then eliminating the errors. First you are finding the errors and then you are removing those errors is called debugging. So what we have talked about. So errors can be classified into three major groups. First is the errors on the basis of syntax, that is syntax errors. Runtime errors, so when you are executing the program, at that time some error occurs, that is the runtime error. And logical error, so you have been told to write a program for the summation of two numbers, but your mind is not clear, you write the program for the multiplication of two numbers. No doubt there will not be any syntax error, there will not be any runtime error, but there will be a logical error because the results as expected is not. We are expecting the answer to be 4, and if we have, suppose this is the answer, so the it should be 6 but it comes out to be 8, so it means it is a logical error, right? But we were expecting to write plus but we have written multiply, so this is a logic error, not syntax, not runtime. So we have three type of errors. One is the syntax error, another is runtime error, another is logical error. So let's know about in detail about the syntax errors. Syntax errors means Python will find these kind of errors when it tries to parse the program. What do you mean by this line? First is we are talking about syntax errors. So first term is syntax. What do you mean by syntax? In syntax, if you can recall, we have talked about when indentation is very important in Python. So indentation means suppose you are writing the for loop, right? And in for loop you are writing some line of codes, and you need to put one tab in front of the line of code that is the part of this for loop. So this is indentation. So you have to write inside the for loop, not at the level of the for loop. So this is your syntax error, right? Or suppose you have to call the function close. Yesterday we have learnt about the file. So you are writing the close, so you are not putting open close parenthesis, but this is the part of your syntax. So if you are not following the syntax of the uh, Python terms, functions, or whichever you are using in your program, so it means you are not following the rules that are defined by the Python. Basically, we can say that these are some of the predefined rules that you should follow when you are writing the program. And if you are not following those rules for writing the program, it means there will be error. So that is a syntax error. So now when this syntax error is caught by the Python, right? So when it tries to parse the program, so when you have written, right, and you say that now, okay, try to run it, okay, so it will try to parse it. Parse means it will try to look at whether you have written that syntax in a proper manner or not, it is acceptable by the Python or not. If it is not acceptable, then it will exit, right, with an error message without running anything, because there is a syntax error. Till all the syntaxes are not clear and all are correct, it will not run. It will give you always error message. So syntax errors are the mistakes in the use of Python language. So when you are writing the program in the Python language, you need to follow certain rules. If you are not following the rules, those are the syntax errors and are analogous to spelling or grammar mistakes in the language like English. For example, the sentence is would you some tea? So this is a wrong sentence, right? If we talk about the rules laid down in the English grammar, so does not, so because there is a missing verb, right? So it is a syntax error in writing the sentence in English. So what are the common Python syntax errors? So these are some of the examples. First, leaving out a keyword. So you need to write a keyword, but you have not written a keyword. Suppose you were talking about for I in like some list, right? So you need to write for and in over here. So these are the keywords, but what you do is for I list. So in is missing over here. So you have missed out the keyword over here. Putting a keyword in the wrong place. For in I list. So in is at wrong place. Leaving out a symbol such as colon, comma, or brackets. So you just remember when we are talking about defining user defined function. So you write def, then name of the function, then put the colon over there. So if you forget to put the colon, it means this is a leaving out a symbol. Misspelling a keyword, so you write fr, not for, right? Incorrect indentation, we have taken the example of incorrect indentation over here, right? Then empty block. So these are some of the syntax errors that you should avoid when you are writing the program and keep in your mind. Let's see more examples over here. First, you have defined my function. So this is an indentation error because return is the part of this. So similarly, so in each and every line you will see there is a problem, right? In the last line, if you look at, if 2 is greater than 1, print this, right? So there is a mistake. Why? So let's see. In the last line of code misses a colon, so you have not put the colon over here after indentation, so it means this is a syntax error and it will be invalid syntax. Then we are coming to the next type of error, that is runtime errors. If a program is syntactically correct, what do you mean by that? So we have already seen the syntax error. So if in your program there are no syntax errors, it means this is syntactically correct. It is it is able to parse your program correctly and it has not thrown any error. It means your program is syntactically correct. That is, it is free from syntax errors. So it will be run by the Python interpreter because there are no errors found while parsing your program. So there is no syntax error, so that's why it is syntactically correct. Now, however, the program may exit unexpectedly. Even though there are no syntax errors, even then your program is exiting unexpectedly during the execution. It if it During the execution it is exiting unexpectedly. Why? If it encounters a runtime error when it is executing your program, it is exiting unexpectedly. It means this is a runtime error. When it is running your program, some error has occurred and it has exited unexpectedly. So this is runtime error. So a problem which was not detected when the program was parsed because it was syntax free, but it is only revealed when a particular code is expected, right? So something is missing that you have not put into it, then it is caught during the running of the program. So when a program comes to a halt because of runtime error, then the program is, we say it is crashed. This is called runtime error, right? Now, what is exception? We have looked at error, right? So we have looked about syntax error, we have looked about runtime error. What is exception? Exception is an error that's detected during execution or runtime. So during runtime, whatever error has been detected, that is called exception. So the programmer should always try to add checks to the code to make sure that it can deal with the bad input and edge cases gracefully. So suppose you are writing a program for dividing two numbers and you are asking the user to enter two numbers. So user has its own choice. It can enter anything as two numbers. You are just asking enter first number, enter second number, right? So let's take the example, right? You're writing a divided by b, so user is entering a, user is entering b, so he can enter any number starting from 0, right? Even b starting from 0. So if that person has entered b is equal to 0, a equal to 1, so it means 1 divided by 0, this is divided by 0 error and your program will crash. So these are basically the checks that you need to put in your code. If this kind of error comes during the execution of program, it should not crash, but some friendly, user friendly message should be displayed onto the screen, and after displaying the message, it should continue with the execution of the program for rest of the code after this. So this is how you should handle your bad inputs and edge cases gracefully by putting checks into your code. So these are some of the examples that we talk about runtime or exception errors. First is division by zero, right? We have seen the example. Performing an operation on incompatible types, right? So sometimes in your program, when you try to do some operation on two operands that are incompatible, so we can say that string divided by 2 incompatible, so you need to handle it properly using an identifier which has not been defined, assessing a list element or dictionary value or object attribute which does not exist, trying to access a file which does not exist. So you should add checks on such type of runtime errors so that it should not unexpectedly crash, but it should display a proper user-friendly message and continue with the program execution. So this is what we have taken the example that A has been entered 1 and B has been entered 0. You are trying to print A divided by B. So it will be error that has been thrown and it is zero division error. So division by zero error that has been thrown and the program has been crashed. Then when Python error and exceptions occur, it prints a 4-line message on the screen it if it is not handled. We have seen it, so let's see. So it is 4-line method, so you can see over here, this is your line 1, this is your line 2, this is your line 3, and this is your line 4. So this is a 4-line method that is displayed by the Python when error or exception occurs and if it is not handled. So first line declares that this is a traceback. Okay, traceback. So you can see here that this is a traceback. Then this means that the interpreter traces the Python exception back to its source. So it will inform you the whole route. Second line tells us the line number for the code that caused the Python exception. Then the third line tells us which line caused the exception, Python exception. And finally, the fourth line tells us the type of Python exception that occurred. And this is accompanied by a short description of what has happened. Now let's see again. So this is, you can see first is traceback, another is this is the Python shell line number, and this is your code line number, right? And this is the line where the program has halted or problem is there. This is type of the problem and description of your error. Then last term is logical errors. So logical errors are most difficult to fix because when you are writing your programs, you are confident enough that I have written your program and it has been executed properly, but why the output is not correct, it is behaving differently. Answer should be displayed like this, but Python is giving, the program is giving a wrong answer. I am not able to understand why is it wrong. So this is how you, this is a logical error and it is most difficult to fix. And when they occur when the program runs without crashing. Now there is no mean of crashing, right? Because your program, you have written the code well, there is no syntax error, there is no runtime error, but it is giving wrong output. This is giving incorrect results, right? And the error is caused by a mistake in the program's logic. Whatever logic you have written in your code, there is a mistake, and that is making a logical error. It is also called semantic errors. Unlike a program with syntax error, a program with logic errors can be run, but it does not operate as intended. It does not operate as intended because it is giving incorrect results. The program won't get an error message because no syntax or runtime error has occurred. They will have to find the problem on their own by reviewing all the relevant parts of the code, because the interpreter is not giving you any hint for that. There is no runtime error, there is no syntax error, and now the programmer has to find it by reviewing the whole code. So although some tools, so how can you debug it? So now we can say that how can you debug the logical error? You can put the flags in between and try to get the intermediate results. Suppose there is 100 lines of code, right? And after suppose 10 line of code where there should be an output, you just try to print something out of the that code snippet. If up to this the result is okay, it means there is no mistake in this 10 lines of code. Then you move ahead again, you print a flag over here, print something, and you try to find the result up till this code. If now the result is unexpected over here, it means there is a mistake over here, there is a mistake, logical mistake in this code. So in this way, what you can do is some tools can flag suspicious code which looks like it could cause unexpected behavior. So you can do a small programming lines of code, putting the flags, putting the print statements, and then try to find where it is behaving unexpectedly. And in this way, you can find your logical errors. So sometimes there can be absolutely nothing wrong with the Python implementation of an algorithm. The algorithm itself can be incorrect because the logic is incorrect. However, more frequently, these kinds of errors are caused by the programmer carelessness. So what are the sometimes we have already seen runtime errors using the wrong, this is not runtime, this is the logical error, using the wrong variable name, indenting a block to the wrong level, right? So using integer division instead of floating point division, getting operator precedence wrong, making a mistake in the Boolean expression, off by one, and other numerical errors. So these are some of the logical errors that you should take care of. These are some of the examples. So here x float, enter the number, you are converting into float. Here you are converting into float. Here you are putting x plus y by 2, the average of the two numbers, right? So because of the order of operations in arithmetic, the division is evaluated before the addition. The program won't give the right answer. So you have entered 3, you have entered 4, so it 3 plus 4 by 2, it will come out to be 3 plus 2 by, because this will be executed first, so this comes out to be 5, but otherwise it should be like this. This is how the problems are coming. So now we are coming to the exceptional handling. We have seen what we mean by errors. Errors are of three types. First is your syntax error, runtime error, and logical error. Now we are moving towards exceptions. All the runtime and syntax errors that are encountered, they are exceptions in Python. And Python uses them to indicate that something exceptional has occurred and the program cannot continue unless it is handled. So runtime and syntax, so they are basically the exceptions in Python, right? So when Python some error is raised, so it means some exceptional has occurred. All exceptions are subclasses of the exception class. So we have a class exception in Python, and then we have the further exceptions which are the subclasses. So the cause of an exception is often external to the program itself. For example, an incorrect input that we have seen 1 by 0, a malfunctioning input output device, etc. Because the program abruptly terminates on encountering an exception, it may cause damage to system resources as well, such as files. So their files may be get corrupted. Hence, the exceptions should be properly handled so that an abrupt termination of the program is prevented. So this is exception handling basically. Hence the exceptions should be properly handled. This is exception handling. Why it is required? So that an abrupt termination of the program is prevented. If the programmer knows that a particular section of the program is likely to cause an error, I'm coming again. If the programmer knows a particular section of the program, you have 100 lines of code, and you know that in first 10 lines of code there can be some error that can occur. It means a particular section of the program is likely to cause an error. They can tell the Python what to do if does it does happen. If some error comes in first line 10 lines of code, what the Python should do? It should not abruptly crash, but what should it do? Instead of letting the error crash the program, programmer can intercept it, do something about it, and allow the program to continue. So after, if there is an error in these first 10 lines of code, some user friendly message display to be displayed, and it should continue with the rest of the program execution rather than crashing the program. So we talk about exceptional handling. We have try except blocks. We have finally block. We have raise keyword. Assertion is there. How to define your own exceptions. So what are the advantages of exception handling? It separates normal code from the code that handles errors. Two type of errors codes will be there. One is your normal code, and another is the code that is handling your errors, right? Exceptions can easily be passed along functions in the stack until they reach a function which knows how to handle them, and the intermediate function don't need to have any error handling code. Exceptions come with lots of useful error information built in. For example, they can print a traceback, which helps to see exactly where the error has occurred. Otherwise, you are finding the error and you are not able to find it. But here you will be able to get the traceback. So let's start with the try and except blocks, right? So Python uses try except keywords, right? Try and except keywords to handle possible exceptions. Both keywords are followed by the intended blocks. We will see the example. So this is your try keyword. Here we are putting the colon, and then you have the lines of code intended. So you can see the word intended blocks that is coming inside. So that then it will become the block for the try. Then there is a keyword except, and they try and accept at the same level, but the code inside the except will belong to this except, right? So try means where we have taken the 10 line of code, where there is a chances of error, they will be enclosed in try. And accept, what kind of error we are expecting. If the error comes, what to do. So try block contains one or more statements which are likely to encounter an exception. If the statement in this block are executed without an exception, the subsequent except block is skipped. If there is no error that has encountered, so there is no role of except block, right? And if there is an exception that has been raised, then a role of the exception block will cover. If the exception does occur, the program flow is transferred to the except block. If there is an error that has been encountered over here, then the control will be given to this except block. The statements in the except block are meant to handle the cause of the exception appropriately. So for example, returning an appropriate error message so that the user should come to know that what mistake has been done, and then it can be improved. So the programmer can mention a specific type of exception in front of the except keyword, like division by zero. The subsequent block will be executed only if a specified exception occurs. If the exception like division by zero has occurred, so whatever the block has been written corresponding to this exception, that block will be executed. So there may be multiple exception clauses with different exception types in a single try block. We will look into it that there may be multiple except clauses, except with this exception, except with this exception, except with this exception. So we can think of that in this try block there can be multiple exceptions that can occur. So we will be mentioning all. Why we are fearing of that? Mention all the type of exceptions that you can think that it can come over here. So write down all so that your program gives user defined, user friendly messages rather than the crashing of the program. If the type of the exception doesn't match any of the except blocks, it will remain unhandled and the program will terminate. So that we will look into the solution that this kind of situation, how can we handle if any of the exception is not occurring but exception is coming that we have not listed in it. Then again we are at the 0 point, right? So how can we handle this? We will be looking into the coming slides. The rest of the statements after the except block will continue to execute it. So once this except block has been executed, so whatever has been written after that, it will continue with its execution, right? So even though there is no exception occur, so this whole block will be skipped and it will keep on continuing with the next program lines of code. Let's see how try and except has been used. So this is the keyword try, then we have put the colon over here, then the line of codes that are written inside. So this is intended block for try. Okay, this belongs to try. Then we have the keyword except, then we have put the colon, and this is the intended block for except, indented block for except, right? So now this is again outside this and they try except and this print statement, they are at the same level. Now 5, you have put 0, so it is 5 by 0. It means, so exception has occurred, so it means when it will be executing this, so it will not abruptly crash. Now exception has occurred, it will go inside and it has printed some error has occurred, and then this is out of the exception, so definitely it will also out of the try except blocks. This is how your exceptional handling has been done. Program has not crashed, user friendly message has been displayed, and it has continued with the rest of the lines of code in the program. Another example, so here again you have a try, you have a except. Here what we are doing is for I in range 3, right? Print 3 divided by I, right? So 3 divided by 0, print I, so I. So here it is trying to print 0. So when it comes to like 3 2 1 0 like this, so it started with 0, right? So in the beginning I has been given the value as 0, right? So it is some exception has occurred, it has gone inside, it printed the error message written over here. So 3 divided by 0, print I value over here. So I has been replaced with 0. And then it is coming over here, this prints. So it is not again abruptly crashing, but displaying the user friendly message. After displaying the user friendly message, it is going to the out of the try except block lines of code execution. Then we have multiple except clause, right? So we should think that as many errors that we can think that can come, we should list all. So try except block can also have multiple except clauses. See this. This is your try block corresponding to first except, second except. Python will check each except clause from the drop down, from the top down. First it will check for this, then it will check for this, to see if the exception type matches. If any exception type matches, it will work for that block. And if none of the except clauses match, the exception will be considered to be unhandled and the program will again crash, right? So here you can see you have written A as 1, B as 0, then you have lines of code that are enclosed in try block. So here it is A divided by 0, 1 divided by 0. So it is exception handling. So first type error, it is not a type error, it will skip it. It will check for 0 division error. So it has found that this is the right exception that has been raised. So it will go inside, you divide it by 0. And after that it comes out of print the dividend may not be 0, right? So when the interpreter encounters an exception, it checks the except blocks associated with that try block. Now you can see that these except blocks are associated with this try block. These except blocks may declare what kind of exceptions can be handled. So it is saying that type error and division, 0 division error can be handled by this try block. So when the interpreter finds the matching exception, we can see that here it has tried finding from top down. First it has tried for type error, then it comes to the 0 division error. So 0 division error has occurred, right? So it executes that except block. So here this is a try block. Again it is 5. It comes like this. So it is type. So same example we have taken. So division by 0 not allowed. So first is valid, then it comes out of the exception block. So it will be displayed out of the try except blocks. Then single except to handle multiple exceptions. It is possible for one except clause to handle more than one kind of error. So programmer can provide a tuple of execution types instead of a single type. So let's see, this is your try block, right? You have written line of code and here it is a except, and this is your tuple of exception types. This is your first exception type, this is your second exception type, separated by comma and enclosed in open close parentheses, and then you have a colon. So this becomes your tuple, and then all the exceptions that you need to mention, they are the items of that tuple. So whichever error is coming, whether it is coming value error, whether it is coming 0 division error, it will display this message. Fine. So here also you can see this is type error has occurred. So it has printed unsupported operation, then it displays this because this is out of the try except blocks. Generic except after excepts. We have seen that if no exception types are matched, the program was crashing, the error was unhandled. So what is the solution? For that you have a generic except statement. If exception has occurred but no exception type is being matched, so it will not crash, but it will go to the generic except block. This is try block. This is the first exception type that can occur. This is the second exception type that can occur, right? If these two are not matched, it should not go unhandled, but it will go to this and it will print this message. So finally, you can complement all the specific except blocks with a generic except at the end. This block will serve to handle all exceptions that go undetected by the specific except blocks. So the first statement under the try block tries to concentrate a string to an int. This raises a type error As the interpreter comes across it, it checks for an appropriate except block that handles this. So type error is not there, so it is going something went wrong. Then we have else and finally statements. In Python, keywords else and finally can also be used along with the try and except clauses. While the except block is executed, if the exception occurs inside the try block, the else block gets processed if the try block is found to be exception free. The finally block, so we'll be looking at the examples to clear about. So thus we have the finally block. Finally block consists of statements which should be processed. Yeah, so look at this, which should be processed regardless of an exception occurring in the try block or not. So whatever the case may be, the finally block will always be executed. As a consequence, the error-free try block skips the except clause and enters the finally block. So finally block always be visited and all the lines written inside it will be executed before going to execute the rest of the code. If, however, there is an exception in the try block, first the except block will be processed and then the finally block will be processed. Finally block will anyhow will be executed whether the exception raises or not. Let's see. So here this is the syntax. First you have the try, then you have the except, then you have the else, then you have the while. Statements in the try block, and this except will be executed when errors occurs in the try block, executed if the try block is error free, executed irrespective of the exception occurred or not. So you have try block, except block, else, finally. You execute run this code. This block will be executed when the exception occurs. If no exception, run this code. Always run this block for the code. So this is always run this block of code. Let's see example. Try, this is your try block. This is your except block, this is your print block, and this is your finally block, and this is your out of your try block. The else and finally blocks is displayed because the try block is error free, right? So first we have seen it is starting with it displays try block. Enter the number has been entered as 10. Enter the another number, enter has been, it is 2. When you z equal to x by y, so it is z equal to 10 by 2, it comes out to 5. Though there is no error, there is no exception, so it means this block is skipped. So when it is skipped, so it will enter into the else block. So it has gone inside the else block, it has displayed the result of the division, then this is no doubt finally will always be executed. So it is finally block, right? And then it will display out of the try, except, else, and finally blocks, right? So try block, enter a number 10, another number you have entered xyz, it means exception has occurred, right? So it has gone inside, right? So then finally block, and then it has displayed finally block, and whatever the traceback is there, it has displayed over there. Raising exceptions. So forcefully you want to raise the exceptions by your own, if it is there is error or not, but you want to raise the exception by using the keyword raise. So Python allows the programmer to raise exceptions themselves by using the raise statement. Raise statement. The raise statement allows the programmer to force a specified exception to occur. The raise statement allows the programmer to force a specified exception to occur. The sole argument to raise. So what argument you should provide to the raise indicates the exception to be the raised. What exception the programmer wants to raise, it should put as argument to the raise. This must be either an exception, instance, or an exception class. If an exception class is passed, it will implicitly instantiated by calling its constructor with no arguments. See example, raise name error, hi there. So this is the exception what programmer want to raise and what they want to display while raising this exception. Traceback file, so it has displayed name error and then hi there has been printed over here. So the programmer can also write their own custom exception classes which are based on the existing exception classes. If the programmer need to determine whether an exception was raised but don't intend to handle it, a simpler form of the raise statement allows to re-raise the exception. Let's see, this is your try block. Here you are raising the exception. This is the exception that we have raised and you want to display the custom message. Here you are handling it except name error. So you are handling that exception. So here you are printing an exception flew by, right? So this is an exceptional flew by and then this has been displayed. So here are the few common exception types which are likely to raise in the above or blue program. First is type error, another is value error. This is an error which indicates that a variable has the wrong type for some operation. We might raise it in a function if the parameter is not of a type what we know how to handle. Value error. This error is used to indicate that a variable has the right type but the wrong value. For example, we used it when the age was an integer but the wrong kind of integer. Like so, these are how the exceptions are raised, right? So this is how you are asking for input. If the x is greater than error, it is a value error you have raised and you are passing the value that is passed, that has been entered by the user. So this is the raised exception. The programmers can also define custom exception types to be raised. So except now you are handling over here. So suppose you have entered 105. 105 is out of the allowed range. So if it is not, so it will say it is allowed range. So you have entered 200, it is written 200 is out of range, so it has gone inside. If you have entered 50, so 50 is within the allowed range. Raise without a specified exception, right? So it is possible to raise keyword without specifying what exception to raise. Then it re-raises the exception that occurred. That is why you can only put it in an except block. So print this is raised. So this is how it has been raised. Some exception has covered. Why the exception has come? Because this is string type and this is the number type. So exception has covered. It will go and it is just raising that. Raise within argument. Raise value error inappropriate value. So it will display like this. Assertions. An assertion is actually a sanity check for your cynical, paranoid soil. It takes an expression as an argument and raises a Python exception if the expression has a false Boolean value. Otherwise, it performs a no operation. Let's see the example. Assert true. Now what if the expression was false? Assert this is false, right? Let's see. So when the assert, you are providing some expression, if the results comes out to be false, so assertion error has been raised. So print 1, it has printed, right? Assert 2 plus 2 equal to 4, right? So it is okay. Then print 2, it has 2. Then assert 1 plus 2 equal to 4. This is an assert failed, right? Because answer comes out to be false, it has gone and this it has printed like this. Print 3, right? So it is finally it is okay, and assertion error has been displayed. Second argument to the assert, uh, false, what to display. So the message what you want to display over there. User time defined exceptions or write your own exceptions. Programs may name their own exceptions by creating a new exception class. Exceptions should typically be derived from the exception class, either directly or indirectly. So when you want to define your own exceptions, they typically be derived from exception class, whether it is directly or indirectly. So in Python, users can define custom or user defined exceptions by creating a new class. So here you will be creating new class. This exception class has to be derived. These things to be taken care, either directly or indirectly, from the built-in exception class. Most of the built-in exceptions are also derived from this class. So we will see the example. Exception classes can be defined which do anything any other class can do, but usually kept simple, often only offering a number of attributes that allow information about the error to be extracted by the handlers for the exception. So in simple words, you should display the error message and how to resolve it. So when creating a module that can raise several distinct errors, a common practice is to create a base class for exceptions defined by that module and subclass that to create specific exception classes for different error conditions. So we'll be looking into the examples. So Python throws errors and exceptions when there is a code gone wrong, which may cause program to stop abruptly. So Python also provides exception handling method with the help of try except. So we have already seen some of the standard exceptions that we can see is index error, import error, IO error, zero division error, type error, file not found error. So user can create his own error using exception class. So exceptions used to be derived from the exception class either directly or indirectly. So although not mandatory, most of the exceptions are named as name that end in error, similar to naming of the standard exceptions in Python. So this is how you can user can define. So this is class my error exception. So you can see class my error is derived from superclass exception. This is important. Then constructor def double underscore int double underscore then self and value, two parameters, self dot value equal to value. So then we have def double underscore str double underscore self return reper self dot value, try raise my error 3 multiplied by 2. So except, so this is the except block, this is your try block. Here you are forcefully raising my error as error, so new exception occurs, so this will display this. So this is the typical. So when you try this actually in your interpreter, you will be able to understand. Another example, so my class, this is my error derived from exception. This is what you want to print, then you are raising it. So it is just raising that error and displaying my so this is my error happened, so it will be displayed onto the screen. Driving error from superclass exception. Superclass exceptions, so this is the name of the class, this is the superclass exceptions, are created when a module needs to handle several distinct errors. One of the common way of doing this is to create a base class for the exceptions defined by that module. And further, various subclasses are defined to create specific exception classes for different error conditions. This is class, then error, exception, right? Pass, then class, transition error, error, and this is how you are defining, and this is how you are raising it. So I'm going a bit faster because you just do it, then you will be able to understand this. So this is the exceptional hierarchy, in which you have the base exception, in which you have the exception, system exit, generator exit, keyboard interrupt. In this, it comes like attribute error, arithmetic error, end of file error, name error, lookup error, OS error, type error, and value error. If you talk about arithmetic error, we have division, zero division error, floating point error, overflow error. If you talk about lookup error, we have index error and key error. Operating system, file not found, interrupted error, permission error, time out error. So this is all about exception hierarchy. Then the classes exceptional, like base class is there, in which we have seen system exit, exception and all. So you can see system exit, keyboard interrupt, generator exit, exceptional, and in that you have stop iteration and so on. So just you can go through all these, you need not to keep in your mind, so but you need to look into when you are writing the program. So these are the exceptional hierarchy for the built-in exceptions. This is the another class hierarchy, you can just have a look on it. This is the another class hierarchy for the built-in exceptions. This is the another hierarchy for built-in exceptions. So these are the descriptions of all, you can just go through by yourself. Base exception, exception, arithmetic error, buffer error, lookup error. Then we have assertion error, attribute error, end of file error, floating point error, generator exit, import error, module not found error. Then we have index error, key error, keyboard interrupt error, memory error, name error, non-implemented error, OS error, overflow error, recursion error. Then we have reference error, runtime error, stop iteration, stop async iteration, syntax error, indentation error, tab error, system error, system exit, type error, unbound local error, Unicode error. In Unicode error, Unicode encode error, Unicode decode error, Unicode translate error, value error, zero division error, blocking IO error, child processor error, connection error, broken pipe error, connection aborted error, connection refused error, file exists error, file not found error, interrupted error, is a directory error, not a directory error, permission error, process lookup error, timeout error. Then warnings, warning, user warning, depreciation warning, pendle definition warning, syntax warning, runtime warning, future warning, import warning, Unicode warning, bytes warning, resources warning. So these are some of the examples that you should go for. Like we have overflow error, zero division error, floating point errors. So here we are just handling them. So this is exceptional lookup error. When you try to find something, so you are trying to find something, you have the lookup error, so it is handled. This is concrete exception programs like assertion error, how to handle it. This is another exception, generator exit. These are some of the references from where we have taken the content and we acknowledge their content. Learning by doing. So this is a big concept that you should practice on all the concepts related to the exception handling. So then you will be able to understand about it. So thank you very much.